Right, well, welcome to this presentation on pathvIEw, which is a code coverage testing tool designed specifically for CAGen. The agenda, start off with a quick introduction to code coverage, then an overview of pathvIEw, then a demonstration, and finally question and answers. So if we look at the discipline of software testing, typically software testing is categorized into either functional testing or structural testing. Functional testing is where you're testing the application's behavior against the user's requirements, and it's sometimes called black box testing because you don't really care what the internals of the software is. You basically set it an input and check the output is as you would expect. Structural testing, on the other hand, is comparing the behavior of the application against the intention of the source code. So it's sometimes called white box testing because you're looking at the actual source code itself to see if it does what it's supposed to do. And these are not mutually exclusive types of testing. You really should be undertaking both types of testing. Testing the application does what it's supposed to do, functional testing, and also conducting structural testing, which helps you measure the quality of your testing effort. Code coverage is essentially a way of measuring the quality of the testing itself by making sure that your tests are actually testing the code completely. It typically provides a coverage metric, the coverage percentage, where 0% means that none of the statements that you've coded in a particular program have been executed at all. 100% at the other extreme means that every single statement has been executed. Note that just because you execute a statement doesn't mean the statement's doing what it should do. So the job of functional testing is to make sure the code actually does what it's supposed to do. But the structural testing or code coverage is measuring the quality of your testing. So for example, if your coverage percentage was low, then that means there is a large amount of code in your application that has not yet been executed, i.e. tested. So the process of using code coverage is to firstly look at the code coverage results and determine which areas of the code have not been executed during your testing process. And the key question is, why is that the case? It might be simply that your test cases are not adequate to thoroughly test the application. So there may be large parts of functionality in the application that your test cases do not cover. It might be that the code is now redundant, so there is no business requirement that leads you into that part of the code. So the code is redundant, will never be executed under any normal circumstances, so it's dead code that could be removed. Or it could be there's an error, so you have some code that cannot be reached because of a logic error. It's supposed to be there, but for some reason it doesn't get executed. But the most usual reason for code not being executed is inadequate test cases. And therefore, the code coverage process helps you to identify what additional test cases are needed to more thoroughly test the application. It might be, for example, you have a year-end run and no one has bothered to do the testing of the year-end run, and therefore your test case needs to be able to test the year-end run processing, as an example. And it's important to note that code coverage testing doesn't help you with the functional testing apart from enabling you to enhance your thought process, so enabling you to identify why code has not been executed and use that as valuable input to improving your test cases. And most people agree that you don't always need to aim for 100% coverage. There may be some code in your application which deals with database exceptions or database errors that you would not normally expect to find, and it would be unreasonable to expect the developer or tester to corrupt the database to be able to thoroughly test all those exception cases. However, if the code coverage is less than a certain percentage, for example 80%, that should be worrying, because it would indicate that you have not thoroughly tested that particular module or set of modules. pathvIEw is a statement-level code coverage tool built specifically for CA-Gen, and it enables you to produce statement-level code coverage for procedure step action diagrams and action blocks, with support for all of the major target platforms like MVS, Windows, Unix, Java, and Gen 6.5 and above. The architecture of pathvIEw: the starting point is the source code that you execute is standard generated code, and it doesn't have to be generated with trace. So you can either run it with trace enabled or without trace enabled, it makes no difference. The source code itself is post-processed by the pathvIEw source code post-processor, and that adds in data collection logic into the generated code, which is then stored in the pathvIEw database. You then when you run the application, the data is collected by something called a region, and a region essentially is a testing region, for example, development, test, QA, user acceptance, and that enables the same piece of code to be executed in different regions and the results segregated. The coverage data itself is sent to something called the pathvIEw listener, which is responsible for storing the results in the database. And the reason we use a separate listener to store the results is firstly for performance reasons. The pathvIEw runtime has a very low overhead, so it collects the data, sends it as a TCP/IP message to the listener, and then the listener asynchronously stores it in the database without slowing up the application. And then once the testing is complete, there is a pathvIEw client which enables the tester to review the results and use that as feedback to improve the test cases. We'll take a look at all of that in the demo. So some of the key features of pathvIEw: firstly, it does not alter the behavior of the generated code at all. It has a very low runtime overhead with negligible overhead for memory and CPU. The listener itself is multi-threaded, so it scales to support large numbers of concurrent testers. And on the mainframe, it can either run as a started task or as a socket listener on CICS. On other platforms, it runs as a service. One of the features in pathvIEw is the ability to set up what we call test cases. So when you're running a test case, then it logs the test results by the test case, so you can see for each test case which statements were executed, rather than just seeing them for any execution. And so that enables you to see, for example, for a particular test case, what code was actually executed. And then, whilst it's optional, if you do have Guardian, then there is very good integration between pathvIEw and Guardian, enabling you to view the code coverage results by change request, release pack, etc. So to summarize, the benefits of code coverage testing is primarily helping you to identify untested code and therefore improve the test cases so that all of your code is properly tested. One of the main problems if you start to use code coverage testing for an existing application is it would be unreasonable to expect the entire application to be tested as soon as you start using code coverage. Now, if you don't test the entire application, then of course the code coverage percentages will be rather low when you first start using it. And the main benefit that we see from code coverage is testing changes that you make to the application. So one of the features in pathvIEW is that it enables you to detect what statements were changed and make sure that the changed statements have at least been tested. So you may have a lot of code in your application that you can't retest every single time you make a change, but it would be much more reasonable to expect that any changed statements are properly tested, and that's one of the things you can do with pathvIEW. It can also help identify redundant code, typically code that is never executed. One of the reasons for that might be that it's no longer needed, so you can clean out redundant code from your application. And if you use test cases, you can help identify duplicate test cases, which are test cases that do the same thing, and that might again reduce the amount of testing you need to do, because you don't need to run test cases that achieve the same result. So that's a quick introduction to the concepts of pathvIEW, and what we'll do now is actually look at the system in action. So what I have is a simple application, and it's this is part of the application, it's our test application, and it's a staff maintenance transaction. And what I'm going to do is launch pathvIEW, and here are all of the action blocks and procedure steps for this application. Now, there's enough on there to look at, but if obviously in a real-world application with thousands of modules, then you wouldn't want to look at the whole lot in one go. So what you can do, you have various filters. For example, I might want to filter on anything containing employee. And here I have the action blocks and procedure steps to do with employee maintenance. Another way of filtering would be if I'm working on a change request, then what I'm going to do is just pick the change request I'm working on, and here I would see the objects that I've changed in my change request. Now, what you see apart from the name of the object is when it was generated, how many statements have been tested, and the percentage of statements tested. So here these two are reasonably well tested, 85% for example, and if I just open that up, essentially the green means I've tested the statement, the red means it's not yet been tested, and the only thing that hasn't been tested is an exit state for setting an invalid command. And because in my application really there's no way of setting an invalid command because it comes from the client, then I could be quite happy with that. And if I was sure that could never be executed, I can actually flag that as manually tested, where it appears in blue, to show that I've made a conscious decision that actually doesn't need to be tested, and then the coverage goes up to 100%. One of the things I have here is an action block, add or edit employee, which currently is not tested at all. So if I open that up, everything in here is red, meaning it hasn't been executed. And what I'll do is I'll just show you running the actual application here, and we can see that as I run it, the statements are executed. So for example, I could take a user and just press apply to edit it, and then I press refresh here, and then I can see immediately the statements that I just executed. And then there's a variety of examples here. So if it's an administrator and the leaving date is set, then you can't set the leaving date for an administrator. So if I wanted to test that, one of my test cases might be pick an administrator and set a leaving date. So I do that, and I get an error, and here if I refresh, I can see then those statements were executed. And then another test case would have to be if I set a leaving date and the status is not terminated, that's not allowed. So if I set a leaving date and the status so I need to pick someone who isn't an administrator. So I set a leaving date. That's the next test case, and it says you must be terminated, and so that statement was executed. And the other way around, if I set the status to terminated without a leaving date, another test case I would have, that's also an error, and again that was executed. So you can see that gradually I'm building up a coverage by running through my test cases. I'm making sure that all the statements were executed. One of the ones I've got here is if this flag is set to Y, if it's a director or manager, then if it's a director you must have a phone number and an address. So what I could do is say, well, that hasn't been tested, how can I do that? And no matter what I do on here, that doesn't work. And so then I'd suddenly find that actually I'm referencing a view here, temp, director or manager, that's not set. So there's no way that code can be executed. So someone might look at that code and think that looks okay, but they might miss the fact that that view is never set. So immediately my code coverage testing is highlighting an error in my code. There's no way of executing that code, and I must actually set that flag to be able to reach that part of the code. So what I can do is come into my action diagram and set the flag. So I'll say if it's a director, then set director or manager to Y. Otherwise, and it's something to do with a manager, and a manager is someone who manages a store. So I'll just copy that logic. So if it's not a director, if the person manages a store, they're also a manager. So now I can execute that logic there. So what I'll do is launch Guardian and just update that action block and regenerate it. So I'm going to pick my change request, and I'm going to upload that changed action block to the encyclopedia. Of course, you could generate it using the tool set or your own way if you don't have Guardian. I'm just using Guardian because it makes it easier to do that. Okay, so that's uploaded the change, and Guardian's detected I changed that action block. And so what I'm going to do is change my logic, regenerate my code. So this is regenerated the code. So if I now go back to pathvIEw, we're back to 0% tested because I have a new version of the action block. Now what I can do is pick the one that I tested before, and I can compare them. And here I can see the statements that I added. So what I'm really looking to do is make sure that I've tested the change statements. So one of the things I can do is change this to changes, and this highlights the number of change statements between the baseline tested version and the current one. So this is saying I've got 4 change statements that I need to test. So just giving you an example of how you can do that. So what I'm going to do now is have this set without a telephone number, and I now get the, if I bring this up, I now have the code that was previously untested. That's now, that part has been tested. This whole process is helping me not only find errors but also make sure that my test cases are correct. So where I find statements that haven't been tested, then that's indicating that I need to improve my test cases to make sure that's all thoroughly tested. So just to finish off with some of the features of pathvIEw, it shows you tested statements, untested statements. If there's a piece of logic here, you say, well, how do I get there? How would I get to that statement? And you may have very many levels of nesting. One of the nice features is you can say, show the path to that statement. And what it does is it highlights in yellow all the statements that would be executed to go from the beginning down to the selected line. So that would be executed. Because these statements are within an if, the lighter yellow shows statements that might be executed. So these darker yellow ones will definitely be executed. The lighter ones may be executed to get you down to that point. And all of the ones that won't be executed are collapsed. So that's another feature that if you're saying, well, what test data might I need to get to that point? By being able to go through the path through the code, you're then able to say, okay, well, it must be an existing job role, and it must be not adding, and the employee must be in a certain status. So that's helping you to decide what type of test data you might need to get to the point where you can actually test that bit of logic. Another nice feature is the show latest execution. So when you're running through some code, showing the latest execution highlights the statements the last time you executed it, the statements that were actually executed. So we often use this ourselves as a form of light tracing. Rather, if you're getting stuck and you think, well, I don't really want to generate this code in trace, but I'd like to know what statements were executed. If you have pathvIEw enabled, you can very easily see what statements were executed in the last test run, and that is at least showing you the path through the code, which in many cases is enough to help you solve the problem. Obviously, if it isn't, you can generate with trace and use the normal tracing type process. But this sort of trace light technique that pathvIEw gives you is also incredibly valuable and avoids the overhead of running an application with debug enabled. Another feature is you can take an action block and see all the different times it was executed. In this case, it's only been executed once, but it tells you all of the different test cases, dates and times when a particular statement was executed. So if I went back to a previous tested version and picked one, you can see again the different times it was executed. And finally, one of the features in pathvIEw is a complexity count, and we use something called cyclomatic complexity to generate a count of how complex an action block is based on the testing path. So an action block that purely had a load of set statements with no logic would be the most simple. It doesn't matter how many statements it has, but there would be only one way through it. You start, you execute all the statements, and you end. As soon as you start to have branches in the code, that increases the complexity because you've got different amounts of test data to test all the different branches. And this complexity count is an indication of testing complexity. And the more complex an action block is to test, the more you need to be careful that you thoroughly tested it. So again, one of the things you can do is monitor the testing complexity and maybe have standards for if an action block is getting too complex, the complexity count is too high, it might need simplifying to make it easier to test, to make sure you've gone through all the paths through the logic to thoroughly test the application. So that's the end really of the demonstration of pathvIEw. Hopefully that's given you a good indication of what the product can do and how it might help you improve your testing process. So thank you very much.